Seems to work. Open recent. Open. Cat, dog, or language. Okay. So let's implement let's implement the LetRec that we were doing. Remind me, what's the difference between a let star, and LetRec?
Let star, you can define variables and parameters with other variables. Or not parameters, but you can use variables to define other variables. So you can do like A equals 5, B equals A.
Yeah, okay, good. Can you define functions inside of a let star?
No, the LetRec is the only one you can define functions inside of. Or no. Okay.
Can you define functions inside of a let?
Yeah.
Yeah, you can define functions. You can define functions in all of them. You can define variables in all of them. In a let star, you can define functions and variables in terms of other variables and functions you've defined in there. A LetRec allows you to call those functions recursively. That's the one thing LetRec gives us that the let star did not, is the ability to recursively call your defined functions. Make sense? And at the end, it is kind of an interesting thing. So if you consider it from a what's the right tool for the job perspective, since a LetRec does everything, I mean, a LetRec will literally work for all of those, right? Why wouldn't you just always use a LetRec? Well, you might say that. Oh, go ahead. Okay, but now, correct, because you would presume that the implementation of a LetRec is significantly more complex than a let star or a let, right? Okay, I mean, we've written a let. That wasn't a big deal. Right? It was actually relatively easy there, right? It was just all about throwing variables into our environment. But so you mentioned performance is our issue. Okay, fine, fair enough. But we're already using a loosely typed functional language, so everything about it is not about performance. It's kind of an interesting twist on it, right? So, I mean, if performance has just already been tossed out the window, why not just use a LetRec for everything? Go ahead.
I mean, if somebody's looking at the code and they see a LetRec is used, they're probably going to expect there is some version for the rest of it. I mean, I think from a readability standpoint.
Yeah, so maybe that's it. I mean, if we're using the correct tool for the job each time, I mean, a person who's going to be nice about performance, fine, we're already using a lower performance tool, but let's not overload it. Let's not throw 3 GPUs on a board that only has a 550 watt power supply on it. Inside joke if you weren't here yesterday when my motherboard was smoking. But so literally, so we're already kind of dealing with a slower language. So if we're going to say, look, we're going to be good programmers, and we're going to use the correct tool for the job and not do overkill, right? And not use the power drill to screw in those little plastic light switch covers. Don't use the power drill for that. They will crack quick. There's a story there too. So I did that to one, right? So that's like a guy thing to do, right? Yeah. Then my wife yelled at me. But then I think, no, I'll just be gentler in this next one. Crack that one too. Never do well that which you do not want to do. So she screwed in the rest of them. It was pretty funny. All right, so in any case, if we want to be good Samaritans and think about performance, use the right tool for the job, and like you said, if you use a LetRec, that kind of implies you kind of want to do recursion. So, a wise person reading your code might be looking for where you're calling your recursive function, something like that. Okay, so we'll come down here. And we have our helper we wrote last time, right? This is the apply expression block helper. So this is the value of that helper. So this guy takes in a list of parsed expressions and an environment. Okay, so that's going to be the value there. It's called apply expression blah. We'll be able to see it up here. So that is in our put a block expression up here somewhere. Where did we put it?
It was not at the bottom.
Was it? I didn't scroll down enough. All right, so if it's a block expression, so here's our let where we get our list of parsed expressions. Those are the expressions we need to work through. We still need those, right? So we're going to upgrade this guy to a LetRec. And then we need a second variable in here besides our list of parsed expressions. We're going to need there's our to list. We're going to have something called apply expression block helper if we just want to keep the names the same. You didn't have to name it that much, but that's effectively what we're doing, right? I mean, maybe if you want to just keep it short, you can just say helper like this. And we can say helper is equal to that lambda. Oh. Well, that seems reasonable enough indentation. All right, so that is the to list for our helper. That's the to list for the body of our LetRec. I'm sorry, for the environment portion of our LetRec. And then here is our actual body of the LetRec. And we're going to be calling helper here instead of our apply expression block helper. Like that. All right, so now this thing is all self-contained. And this function isn't even necessary anymore. And if we want to just test this real quick, we'll run this guy. And I think that was our correct answer at the end.
There's one other spot you need to change it.
I'm calling the helper down here. So this guy here, so it still works because it's still calling this dude. If I dump this, you'll see it break. So there's its break, because this guy actually should just call helper, because it's recursively calling our function. And there's our answer. Okay, so that was the homework, right? Just to upgrade to our LetRec, and we've kept things all within apply expression rather than having these extra helper functions laying around. That's probably smarter. Give me an example when a helper function would make more sense than doing what we just did here. This wouldn't be a good example of that, but give me an example of when a helper function might make more sense.
We were using like the same helper function for some reason, the parse expression and apply expression.
I think you have the right idea. A little bit of a bad example. If let's say you're going to use the same helper in more than one of our apply expressions. So we had one function that 3 different parsed expressions happen to use. You could do a LetRec 3 or 4 different times and have the same lambda in there, or you could just external it, or you can have your entire apply expression live, the body of it live within a LetRec. Oh man, that would be nice. Then we can squeeze our whole environment implementation into there. Just everything. Just one function. Oh my god, that would be legit. That's homework. It actually wouldn't be that bad. It would just be a lot of copying and pasting and just kind of like, why? Because then what you've done is you decided, look, we can't use this environment for anything else, any other kind of thing we want to use. It is part of the interpreter. Okay?
It's actually not that crazy of an idea, because eventually it become worthwhile because if we ended up expanding this in enough different ways that this just got really long. We could split it into like 3 or 4 different
like modules.
slides, yeah, where you're just doing initial checks. So like let's say like if it's a list, let's call this apply expression. If it's not a list, let's call this apply expression, and you would end up using the lets inside of that, I would think.
Okay, but so you're saying have more than one apply expression, not a master apply expression with a LetRec that has
But I'm saying
kind of sub apply expressions within it.
if we split it into modules where we could utilize the same things in a let, I think it could make sense.
Yeah, I see. You probably could make an argument for it. I'm just not sure it necessarily helps us that much. But other than just being
No, it doesn't.
like,
I don't think that'd be
it would be like nerd fun. Doesn't that sound like a fun thing to do? Really, you don't just spend your weekends thinking, man, if I could just throw this all into a LetRec, wouldn't that be exciting? It's not it.
Because I mean, I could even make the argument now that it would make sense to split it into 2 modules and list and modules because you'd be doing less checks at the end of the day.
That's true. I mean, isn't it fun solving interesting problems? That's fun.
That's an interesting problem.
Yeah. Like last night, we spent an hour and a half with Unity. We had some realistic looking water, and it looked like it was flowing and stuff. And when you swim under the water, you want it to look like you're underwater. Way easier said than done. But we did it.
Would you just drop the opacity or something?
No, you would have thought that you would need to do something like that. No, it ended up being like a blur effect, but we had to put a blur effect on the textures as well as the camera.
Oh dear.
Yeah, it was pretty. I mean, in the end, the actual amount of code to do it was like 4 lines, which is a very special 4 very special 4 lines. And then you had to put a collider on the surface of the water to determine whether you were going under or coming out to take the blur off. Otherwise, when you come out of the water, it's like me without my glasses or contacts. It's like we're going to look for blobs of stuff and just don't run into the blobs. Yeah, but that was exciting. It was an hour and a half of just pure joy. Doesn't that sound fun? That's not how you spend your weekends? People. All right, so let's look. We have Alexis told us we have a bug with plus plus, right? And potentially minus minus. Let's try minus minus real quick and just see how bad the rot goes. Otherwise, we'll just have you fix it for homework. That is definitely something I probably will do. All right, so I could lie, or we could. All right, so let's go minus minus d. Actually, that's not how it works, right? It's minus minus d, and then plus plus r. That would be the equivalent. So this should give us, the hope would be is this our, we got a 10 here, didn't we? Where'd that 10 come from?
It's from the let test.
Oh. What were we doing there? Oh, I was showing how LetRecs work. Okay, that's right. Let's get rid of that because I confuse very easily. Which is bad news for all of you probably. Okay, so we're going to try to do a minus minus d, which should give us a 2, and a plus plus r, which should give us a 14 is the idea. And let me just look at the output. Am I not calling apply anymore? No, I'm calling apply program. Where's my answer? Oh, here's my answers. Here's my 3 and my 13. So we're hoping to get a 2 and a 14 here. Let's see what crashes. We know the plus plus crashes. We probably should take, actually, let's take the plus plus out. We'll just do 2 minus minus. Big money, big money. Oh, probably the same bug in both of them. All right, expects a number as a first argument given false. Why did I get a false? Okay. So let me. So here is our ink expression. So
we
we're.
still have it change ENV and everything. We didn't switch it to scope. All our scope stuff.
Well, didn't I call apply NV? Or we don't, it's not called apply NV anymore. It's now called what? Resolve?
I think so.
Resolve var. This guy takes a scope stack and a variable name. All right. Resolve, man, is it that? All right. Let me copy that. All right, so that's for ink expression. This is for deck expression. Okay. Now, change env was a because this does modify it. So this is again another. This is our old environment thing. So we need to call. Oh no, this is our. Oh no. Change env is from our old environment. Have we already dumped all the old environment stuff? We have not. Okay. Let's get some of that stuff out. All right, so let's dump all this. That's all old environment stuff, right? And we have it copied in Slack in enough places that it's not like it's gone forever. Now we have our empty scope stack, add scope, create scope, extend scope, get first scope, get rest scope, get first pair. Resolve var in scope, resolve var, add pair to scope, add pair to local scope. So we need to update. So plus plus and minus minus are going to require us to actually update our scope. And we don't really have that yet, right? We have the ability to add a brand new variable. We wrote that for define. But now we have to have the ability to say, I need to change the variable name D to be a new value. Does that make sense? And we don't have that ability with our scope stack right now because plus plus R or whatever results in that value permanently being a higher value. Okay? So we're going to have to write a, there's our add pair to scope, and add pair to local scope. So let's do this here. So we need to have the ability to update a variable in our scope stack. Maybe the most local version of a variable in our scope stack. So if I say plus plus D, it's going to find the most local version of that variable and replace its value with this new, with the new value that we're passing in. Okay, so we'll do define update scope stack. And this guy will be a lambda taking in a var name and a new value. Okay, and we're going to search through this scope stack looking for a variable. Do we have a has binding?
I think you took that one.
That was for extend?
Yeah.
So I'm going to write a couple of helpers in here, and that's okay, just because we've already broken this up into some helpers. So let's first ask a question whether or not a variable is found in a scope. So we're going to say, here, let me, just close this off for right now. This guy will be ability to check to see if a variable is found in a scope. This is define has binding in scope. This would be a lambda that's going to take in a scope and a var name. All right, now remember, what's a scope? A scope is a list containing, the car of it is scope, and the rest of it is two lists. Is it a list of two lists or flat scope, and then a list of two lists? So the catter is the list of two lists, so we're looking for it in there. Okay, so has binding in scope. This guy will take in a scope, and we're going to return true if the variable we're looking for is found in that scope, in the to list of that scope. Okay, so it would be beneficial for us to go ahead and have that list of two lists available to us. So maybe we can do this. Let's just start it as a let. We can upgrade it if we need it to be. So we'll say let pairs equal the catter of scope. Right, that's going to be our list of two lists, our list of name value pairs. Okay. Then we want to look through that guy, trying to determine whether or not it has a variable name equal to the name we're looking for. Make sense? All right, so we're probably going to need a function to do that. We could do it as a helper function, but this might be a good thing to have self-contained, because we're already kind of pulling apart our scope, and now all of a sudden I have this like non-scope stack actual part where I have this list of two lists, which we know what that means, but it's actually a component of something larger. And if I create a helper just for dealing with that, then it's kind of this random helper. We're not sure what kind of value to send it. Where in this case, we know we have a list of two lists. So right off the bat, well, we actually can still leave it as a let here because we don't know that we're going to have to call it recursively yet, but we can think forward and say we're going to have to call it recursively. So we'll have our pair, first of all. Then we're going to want to have a lambda that can go through a list of two lists, specifically our pairs list of two lists, and tell us whether or not the variable name found in there is something that's already been defined. All right, so we'll go ahead and just upgrade this to a LetRec because we know we're going to have to keep calling in on the coder of that list of two lists until we finally get there. So we're going to have our LetRec. So we're going to have our pairs. Those are the guys we're working with here. Then we're going to have a lambda. So let's call this guy check var name. And this guy will be a lambda that takes in a list of pairs. And he will, it's going to take a list of pairs as well as, we don't need to take in the var name because we know the var name from up here. Okay, so he's going to take in a list of pairs and he's going to return true if this var name is found in the variable name portion of that list of pairs. All right, so now we need to write the body of this lambda. So I'm going to actually kick this down a line. All right, so now in here we need each individual pair. So we'll ask the question, if null list of pairs, go ahead and return false. We've run out of places to look and we have turned up empty. We didn't find the variable name you were looking for. If I still have something in there, if I'm in this else, I know I have at least one pair. All right, so we'll keep this extra scary. So we like that, right? So we're going to go ahead and get ourselves the variable name of that pair. So we're going to create a let, and we're going to say, actually, let's create a let. Oh, this is perfect. Perfect for let star. So we're going to say let star, and this guy, the first two list, or the first pair, will be, we'll call it pair, and this guy will be the car of list of pairs. So that's going to be our single to list. Then our second variable will be pair var name, and this will be the car of pair, right? Let star lets us define things in terms of previously defined things. So this will be my to list, my name value pair. So the first element will be my variable name. The second element will be my variable value. And then pair var name will be the first element of pair.
Wouldn't it make more sense to just originally reduce, instead of ever defining something called pairs, wouldn't it just make more sense to reduce it to just a list of names?
Well, we have it as a list of to lists, though. How do you want to? I mean, oh, okay.
Map car to
Yeah, you can. Yeah, you would map car across that,
across.
and then search that individual thing. I don't know if that's actually going to help us. I think at the end of the day, you're doing the exact same logic because you're going to still have to make the recursive call, and each time you're going to have to take the car of the thing because that's what map is going to do. It's going to go through and apply it to each thing. Now, what he wanted to do is he wanted to take our list of to lists, and he wanted to map the car function across that. And if you map the car function across that, you'll be left with a list containing only the variable names, right? Because you'll take the car of each individual element of that list, which is effectively what we're doing here. So depending on how efficiently map is written, that it might be better. It actually might be. So not a, I mean, it's actually kind of a fun solution. I do like using map a lot. Like a lot.
I just think that logic is also easier to write at the end of the day too.
Could be. So we have our list of pairs. This is our lambda that's going to take in a list of pairs. But really what you want to do is you want to call this guy a list of var names. And what will pass that is going to be a flattened list of just variable names. Yeah. We'll have to remember to pass it the right kind of animal then. So list of var names. So if no list of var names, return false. Otherwise, but then we don't need our let star. That is disappointing, actually. All right, so
Map for Let's Start.
what's up?
You're trading map for Let's Start.
See, exciting. We have like little party favors. What is it? The things? Do they make those still? You blow into it and the thing unrolls. Yeah, we need some of those for the final. All right, so see, I just said that somebody's going to bring them. Just watch; it's going to be a thing. All right, so extra credit. All right, so if we're out of things to check, return false. Otherwise, if car, that guy, is equivalent to our var name that we're looking for, return true. Otherwise, call check var name on the cooter of list of var names. So that's our check var name. That's the end of the variable definition portion of our LetRec. And then what we'll call in here is we're going to call check var name. Well, we could do the flat piece too. Yeah. So let's put it up here after pair. So we're going to say list. Let's just call this var names. So var names will be the map of the car function across pairs, which will give us the flat list of var names. All right, so now we're here. So we'll do check var name on var names. And that's has binding in scope. Go ahead.
Isn't this just returning if it's in the scope? Just true, right?
Yeah.
Couldn't we have just done if resolve var is not equal to false?
Yeah. We could have called resolve var on it and just try to resolve it. That wouldn't have been as fun.
You should also really throw a question mark in there.
Do what now? Oh, yeah. Make it a predicate. Way to go, Andy. It's the type of stuff you're supposed to be looking for.
Doesn't a predicate only take in one variable?
Yeah, usually. Predicate-ish.
Oh.
Predicate-ish. 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 It's on the final. Predicate. Define predicate.
Spell it wrong, do 0.
I won't provide a spelling. And Mr. Gonzalez is going to make up the spelling for it. Mr. Gonzalez has a new relative. Yeah, we got an elf on the shelf for my nephew, and because he wanted a Mr. Gonzalez, so we got him. His name is Superfly Nacho Alvarez. He's a skydiver from Amarillo, Texas, and he's Mr. Gonzalez's identical twin cousin-in-law.
So Vlad's significant other?
Well, Vlad's.
Because Vlad's his identical twin cousin.
Oh, that's right. This is cousin-in-law. Oh, yeah, man, that's even better. So, because that gets controversial. Because specifically, his name's Superfly because he's a skydiver. He's a skydiver and he actually is famous for, he's the world record for opening the chute the closest to the ground. 3 inches from the ground is when he actually pulled the chute. And then what's funny is I happened to be, I was browsing the web this morning, and this is just randomly connected. This is how my world works. And at last year's Macy's parade, let's bring up this is pretty funny actually. Last year's Macy's parade. Just open up this is fine. So Macy's parade, elf on the shelf. It actually looks like this exact same doll we got, and he's in like a position like he's about to open the chute, like right before hitting the ground. So you notice there's no chute open yet because he's waiting. Hasn't happened yet. Yeah, and then and then he has his own logo. So I just did a search for Superfly logo, and there's like a Superman one. There it is. That's his logo. Do any of you know who Superfly Jimmy Snuka is? Does that sound familiar to anybody? So you were a wrestling fan growing up? I don't even know if he's still alive.
I don't think he is.
Jimmy Superfly Snuka.
I think he passed away either earlier this year or last year.
Oh, really?
Yeah.
Interesting.
Like, it was really recent. If you left that logo up there any longer, DC might issue a DMCA takedown on the video.
Really? No, I don't think that's not a legitimate logo, is it? You think they would just match it to Superman?
Yeah. Look how he took your idea. Great.
Could be. Yeah, I don't know. I thought that was interesting. That, my made-up story started becoming more of a reality based on complete happenstance. But, it's not a made-up story. These are real things and people and stuff.
How do you come up with
I don't know. Because I gave my wife the homework when I had class last night to go and come up with a name. And she's not, I guess, creative like me in a psychiatric type of way. and so I told her the trick is you just have to sit there and stare at it until the name just pops in your head. You just keep thinking about it until all of a sudden just the storyline starts unraveling. I think that's how authors probably write books, right? Don't they? Because I think there's actually a movie that's coming out soon, like the Father of Christmas or something like that. The guy who wrote the book Scrooge or the play Scrooge or something like that. I've just seen the previews, but he locks himself in this room until the story reveals itself to him, and he's trying to come up with the character's name, and all of a sudden Scrooge appears to him as an apparition, and he's talking to him, and they're writing the book by having these conversations with imaginary people.
Schizophrenic much? Oh my god.
Yeah, but well, at least mine's dolls. Oh yeah. All right. So you're saying I should make a new appointment with this. All right. So has binding and scope, but as you pointed out, we certainly could have leveraged our resolve var. We would have actually called resolve var in scope, looking for a false.
I just did if not equals resolve var false, then return true.
Well, but if we're passing this guy a scope, so if this guy's taking in a scope as a parameter instead of a scope stack. So actually, thinking about what we're going to try to do here, your solution is actually better. Because the whole idea here is we were writing has binding and scope as a starting point for has binding and scope stack, where we were going to have to search through each individual scope in it. So effectively what he's pointed out is, look, we already have a way of looking for a variable inside of a whole scope stack. So it's going to give us, if it gives us anything other than false, it's there. It has binding, right? So we can decide to abstract it here. So if we write, I'm just going to write the second part. So let's just say ability to detect a binding within a scope stack, like this. So we can say define has binding in scope stack. And this guy would be a lambda that's going to take in a scope stack and a var name, making this guy a predicate. This is a predicate. And then we're going to return, we'll make a call to resolve var in, this is just resolve var, right? That takes in the scope stack and a var name, the thing we're looking for. And we want has binding and scope to return true if this guy returns anything other than false. So this will be not this. That's what you wrote, right? That.
No, I didn't. Oh, I didn't save it, but effectively,
Oh, so you did it worse. I was about to give you props. Why'd you put that in an if statement? You said if this is true, return true, else return false?
No, well, because that returns the variable. So if it doesn't return.
Oh, you're right. This is wrong. He's right. Oh my gosh. See, I was testing him, obviously. You know what? You might have just earned the class no homework for the weekend. Everybody has to give him a hug on the way.
First and only time in 4 years.
Yeah. So, because like he said, especially since this is a predicate, the implication is this is going to return either a true or a false. In this case, we returned a. Oh no, I think mine was right.
No, because resolve var returns the var.
But not returns a.
Well, if it's the not of a bar.
Yeah, what would not? So the question is what is what's not a? Actually, it would be like not 3. Yeah, so this actually just wouldn't work. The logic works out okay, presuming that it gave you something that was notable.
Right. Which it does if it's false, but if it's true.
Yeah. Right.
So it's just that if
All
it's
right.
not false, return true.
Yeah, you're right again. Yeah, so he wanted to ask if this guy was equivalent to, actually, we don't even need to ask the not. So we're going to resolve the var. If this is equivalent to false, the var boiled down to false, we get a little sketchy here because now we've effectively said we can't store Booleans, right? Our language won't allow for Booleans because of what we return for resolve var for something that is a, if we don't find it, we're returning a false. Well, couldn't that have been the value of a variable named a? Maybe a is equal to false. So we've disqualified Booleans in our language, at least for the moment. All right, so if we're equivalent to false, return false. Yeah, we could actually just return this guy.
Yeah.
So you still didn't need an if, you just needed something better than a not. And the question is that no homework worthy? I mean, who is more wrong? That's the real question. I mean, his answer would have worked. Mine technically was trying to take the not of just stuff. I mean, it just could have been an ice cream cone. I mean, it could have been anything, really. Yeah, I think so, too. Yeah, it's the thing. Yeah, okay. So has binding and scope stack. So this guy does our catch-all for this, right? So this has binding and scope. This guy was fun. He was cool, especially the map thing. Where's my map thing? Where's my map? Oh, there's my map thing. Yeah, that was a good one. Love map. There is definitely going to be something in the final dealing with map. Oh, it's like my favorite. And we're not going to get to it. I usually don't get to it in this class, but there's something in Scheme that's called an infinite stream. It's pretty slick too, where it's a generator of number patterns. So you basically say, like for instance, like the Fibonacci sequence. So you teach it how to generate numbers, and then you just can keep asking. It'll give you the next thing in the sequence. Forever. As long as you keep asking it, it'll just keep producing the next thing.
So you can give it a function that does something to the number.
Yeah. So it's kind of a mappy type thing, but it produces a kind of a requestable stream. It's like a gumball machine you'll have to put quarters in. It always is full.
Stop working on this and just work on that for the rest of the semester.
Okay, so has binding, and so we can actually. We want to dump this. This was a fun one. I don't want to.
Keep it for memory.
All right, so that's artwork. Bang, bang, bang. All right. All right. So that's artwork. All right. So next class, we will finish fixing plus, plus, and minus, minus. I'll give you a reprieve over the weekend. Remember, though, you do have... actually, did I just put it up yesterday? I announced it last class. You have your Bible verse, but it's due midnight Sunday. And then the next one is already up as well, and it's due midnight the Sunday right before finals, just so you have a little bit more wiggle room for like time management when you're studying for stuff. And we'll talk about the final probably next Friday or whatever, but it's going to be pretty similar format to the midterm, so kind of plan on that. All right, have a good weekend.